Okay, everybody. So I'm going over a few problems. These are the ones I'm going to be going over: 2, 34, 36, 13, 19, 28, 30, 31, and 37 in this video. These are the ones people ask me for. So problem number 2. At 2:30, the hands of a clock form an angle of 105 degrees. Well, actually, that's unknown. You don't know that yet. You need to find out what that angle is, but this is how you do it. So I made a little clock, and it's 2:30. Now, the trick to this problem is that when it's 2:30, the hour hand is going to be halfway in between 2 and 3. That's the trick, because a lot of people think it's going to be right on the 2, and then this will be 2:30. But actually, the hour hand moves as the minute hand goes around. So we got to figure out what each section is. There's 12 sections divided by 360. What is that? 30 degrees each. So each of these is going to be 30 degrees. So let's count the sections. 1, 2, 3.5 sections. So 3.5 times 30 degrees. Yeah, I guess that's 105 degrees. 3/30s would be 90, plus half of 30 would be 15. 90 plus 15, 105 degrees. So that was right. All right, number 13 talks about finding the length of arc DF. And you remember the formula from the notes. What is it again? N over 360 pi d. So you got 45 over 360. I think that's 1/8 of pi times diameter 16. The radius is 8, so the diameter will be 16. And so it'll be 1/8 of 16 pi, which will be 2 pi. That's the length of that arc right there, arc DF. Okay, let's see. Next one, problem 19. What is the measure, or actually the measure of angle P is what we're looking for. We already know it's 40 degrees because I have the answers here, but let's see. From the given clues, I think this is arc AN is 40, and arc AB is 58, and arc CM is 34. So these are tangents. I know those are going to be equal to each other, those tangent lines. Let's see, do I have a diameter here? Yeah, this is circle O, so this is a diameter. So if I use my calculator and subtract 34 and 58 from 180, 180 minus 34 minus 58, so this is 88 degrees. And of course, this would be 140. So P is that exterior angle, so it's going to be this big arc, which I guess is 360 minus 140. What's 360? What is that? 360 minus 140. What is that? 220? I think all this adds up to 220. So the measure of angle P will be 1/2 of 220 minus 140. 220 minus 140 is 80. Half of 80 is 40 degrees. So it is correct. It's 40 degrees. All right. What was the next one? 28. This is a tricky one. This one was in the notes, and I told you this one is going to be really tricky. If this arc here, since these are tangent, if this is x, this one in here will be 360 minus x. Okay, so this outside angle will be 32, will be 1/2 the difference of the big one, x in this case, minus the little one, 360 minus x. So to simplify this, you're going to have to distribute a negative through there. I'm going to first multiply both sides by 2 to get rid of the 1/2. So this will be 64 equals x minus 360 plus x, if I distribute that through there. Then I'll add 360 to both sides. What's 360 plus 64? 360 plus 64. 424 equals 2x. So then x would be 1/2 of 424. That'll be 212 degrees, I think. Yep, 212. That's what it says. All right, this one down here, number 30. This is a diameter, goes through center C, so you know this is going to be a right angle. And, ooh, this arc is 6x. So then this angle would have to be 3x, half of that. So what am I looking for? I don't even know. Oh, I'm looking for what x is. So I could say that these two have to be complementary. 2x minus 5 plus 3x has to add up to 90. You could say all three of these have to be 180 since a 180-degree rule, but I'm going to do this instead. 5x equals 95, x equals 19. And yep, x equals 19. 31. This is that one case with the, you got to find the segments. So the outside times the whole thing. So I'm going to say x, which is the outside segment, times the whole thing, x plus 5, equals 4 times the whole thing, which is 2 plus 4. So x squared plus 5x equals 6 times 4, 24. It's a quadratic, so we solve quadratics by setting it equal to 0 and either factoring it or using quadratic formula. So I'm going to go ahead and try to factor this. Oh, this is 24, sorry. So 8 and 3, right? So is it x plus 8, x minus 3? I think so. Equals 0. X equals negative 8 or positive 3. There's no way x could be negative 8 because distance can't be negative, so we'll throw that one out. So it's just 3. All right, what's the next one? 34. Yeah, still tricky. Diameter is 24. Goes through the center of the circle, and this chord is 6 centimeters away from the center. So it's like this. I'm going to draw, this is the key to this problem. I'm going to draw this radius right here. Now, if the diameter is 24, that means the radius is 12. So then this would be 12. And then you see the little right triangle, right? So then we can figure out what this is. You could say 6 squared plus x squared equals 12 squared. Or you might recognize this as a 30, 60, 90 triangle, you know. If you did, you know, because the short leg is opposite or is half the hypotenuse. So then this would be a 60-degree angle right here, and that'd be a 30-degree angle, which means x would work out to be 6 root 3, I believe. But if you still do Pythagorean theorem, you'll get 6 root 3. And then you got to double it because, you know, you got x over here too, and they want the length of the whole chord. So 6 root 3 doubled is 12 root 3. Down here, find the area of this segment. I noticed this arc is 120. So then this central angle would be 120. So this is a 60-degree angle right in there. And if this whole distance is 8 root 3, then half of it would be 4 root 3. From here to here, this would be 4 root 3, and that's opposite the 60, the root 3. So then this would be 4, and this would be 8. So my strategy is to find the area of the sector minus the area of the triangle. So the sector formula, if you remember, is n over 360 pi r squared. And the triangle formula is 1/2 base times height. So let's plug in our numbers. The sector would be 120 over 360. Pi times the radius, which is 8 squared, minus base and height of the triangle. The base of the triangle is 8 root 3. And the height of the triangle is 4. So this is 64 pi. This is going to be 1/3. It's going to be 64 pi over 3 minus, what's half of 32? 16 root 3. And that's what they got. Okay, the last one is a construction. I think I'm going to have to fold this over because my document camera is getting in the way. All right, let's see if I can pull this off. I think the first step is to draw a ray through there. And then we do the perpendicular bisector through P. So I make a little arc, and I come over here and make a little arc. Now those points are equally distant from P. Now if I do the fish, I've got to spread it out a little bit more than halfway. If I do the fish now, construct the perpendicular bisector where those arcs meet, that should go right through P. And you can go back and review how to do this. It's pretty close. Messed up a little bit. Just make that a little bigger. Yeah, that's what I do. All right, and then AT. There is a video I made on these two constructions. Obviously, it's not going to be on your test. Your test is multiple choice. I can't really check your constructions through the internet. But I want you to know how to do it. So this one works a little differently. You start off by doing the fish through A and T. Like so. That gives you the perpendicular bisector of AT. And then you use this as your center, where those lines meet. And you set your compass so that it goes through A. And it should automatically go through T as well if you did your perpendicular bisector construction correctly. So you get this circle. And then where the two circles meet, here and here, that's going to be your point of tangency. So then you just, from point T, you connect that point to that point. And do the same over here. Where is it? It's right here. This point, the point T. Connect those. And there you go. You did your construction of your outside tangent points. And the whole reason this works is because if this is a true tangent, then this is going to be a right angle right in there. And the same here. And so, right here. And so this is the diameter, right? And this is, that guarantees that to be a right triangle. And then this guarantees, because of that right triangle, this guarantees this to be a tangent, because a tangent is always perpendicular to the radius. So hopefully that makes sense. Talk to you soon.